So this is a video just to explain some of the script files in the CCTV project. I haven't explained them all because some of them are very simple and they really don't sort of take much explanation. But I picked out the ones which either do something interesting or require a little bit of explanation. So the first one is this check Wi-Fi script. And what I do is I run this from a cron job, so every 5 minutes, and the script, what it needs to do is actually check to see if the Raspberry Pi is connected to the network or not, because sometimes I found that before I had this script that the Raspberry Pi would go off the network and it would just stay off the network, and I thought the Raspberry Pi had actually crashed or something. So I rebooted the Raspberry Pi and found out it was actually recording video still, and it was just that it had lost connection to the Wi-Fi network. But with this script, since I've had this in place, it's run for weeks and weeks, and it hasn't ever. Well, it must have probably dropped in the network connection, but it's successfully reconnected, and I've never had to reboot the Raspberry Pis or anything like that. How it does it is it does a simple network ping, so it wants to get a response from the router. Now, if your router IP address is different to this one, then you need to change this IP address to your router IP address. And after it does the network ping, it looks at the result, and if it was a successful ping, it says it reports the log file. Okay, nothing. The Wi-Fi is up, and I don't have to do anything. But if it was a fail, then it just puts in the log file like there's an issue with the network. So it's going to try and reconnect. The first thing it does is it takes the network interface down, because the network interface is probably up. It's just disconnected. So just to make a clean reconnection, it takes an interface down, waits a couple of seconds to make sure it's down, and then it brings the Wi-Fi connection back up again. And that's been successful in actually reconnecting to the network when it's had issues. The next one is this file www.frame. So this is more of interest than anything. So it kind of shows how versatile these H.264 video files are, which come from the Raspberry Pi recording. You can actually do lots of hacking around with them without having to worry too much about the format of them and how they are. So what this script does is through the web interface that is provided with the CCTV project, if you ask for a frame of a video, like a still image, this script finds the latest video file which is currently recording. Then it takes a bit off the front of the video, so I'll actually go through this actually. So what it does here is it looks to see if we're dealing just with JPEG files which are recording currently, because sometimes a CCTV camera can be just recording JPEG images in the JPEG mode rather than video mode. If it's in that mode, then it will just copy whatever the latest image is onto the web server, and it just displays that. That's really quick to do. Otherwise, if it's a H.264 file, which is the latest thing recording, it will say okay, it's currently a video file, and you can take the the first bit of the file, which is like header information, which tells the video player about the format of the video file, and it's like resolution and things. So I just take a big chunk of the front of the file just to make sure I've got the header, and I just put it into this place where I'm going to get the frame from. And then I also take a even bigger chunk of the back of the file, so the most recently bit recording. Take a big chunk of that. You need enough of a chunk that there's things called keyframes, and so keyframes happen say every second or something, where it records a whole frame, and in between that you get like progressive updates. So you need to make sure you've got a full keyframe in order to get a good image. It just appends that to the file where I put the header. So now in theory I've got a video file which I've mocked up myself, which will actually play in a video player if you wanted to. I use this tool called AVConv, which used to be a utility called FFmpeg, and you can convert one video format to another using this. So all I'm doing is I'm saying take the file which I've generated, which I've hacked together, and it's saying select a bit of the 1 second. I think it's 1 second from the end, or 1 second in, or something like that, or 60 seconds in. I can't remember exactly what I did there, but I think it was select the bit which is 1 second in, I think, something like that. 60 frames, so that's 2 seconds in, sorry, and we'll get one frame from that and put it in this image file. So it's basically converting it into an image, which is the 60th frame of the video file, which I've hacked together. And then it just checks to see if there's a log file being generated. So if we're in IR mode, IR hardware detection mode, it will also copy across the last bit of the IR log, detection log, onto the web server, so I can display that in a web page as well. So that was more of interest to see how that works. And I've got IR Motion, the Python program. So this is the most complex bit of the project, and it's only if you're using it in IR hardware detection mode. And I'll quickly go through this. So here we set up things which the user can change when you want to if you want to configure it. So I'm using these. You can use many GPIO pins. So you could have, in theory, many infrared detectors which can trigger recording. I've only got one, so I'm using GPIO pin 15 for that. This period is how frequently it checks the infrared sensor for motion to decide whether to start recording or not. And then the record period, so it will record a period of 60 seconds, but if it gets triggered again in that 60 seconds, then that period will start again 60 seconds from the re-trigger. So it will record as long as it gets infrared motion detections, from a minimum of 60 seconds to a maximum of whatever the last one was plus detection was plus 60 seconds. And this is the shell script to start recording video, and this is a shell script to check to see if the recording is still occurring. So I'm using an external, the Raspberry Pi video recorder, the command line one, and just in case that stops recording for any reason, or if it gets to the end of the period which I've asked it to record, I've got a command which I can do, say check and see if it is still recorded or not. Then there's a log file where I output log events from this Python script so that I can see what events have occurred. Now there's two functions within this Python script. One is I've called it a key press callback, but really it's the infrared hardware detection callback. This is where I've copied and pasted code. I haven't bothered renaming the function, but it's it was supposed to be event triggered. So the GPIO in Python, you can do event triggers, but I found that there's an issue with the Raspberry vid utility, that if you use that, it triggers it first time, but then it doesn't trigger it again on this connect. So I'm changed it to a polling system, but I've still got this function in here, so it goes switch back if that ever gets resolved, that issue. And I'm using a couple of global global variables. Sorry, one is the time which the last event triggered, and another one's record flagged, so it's a flag whether or not the Python script thinks it's currently recording. So the first thing I do is, so this is a trigger event, so the infrared detectors detected something, so I set the trigger time to the now time, with the time date that it is now, so that I can measure 60 seconds from now. Then I run a command to say, am I currently recording or not, or is the actual command running for if it's recorded or not, because I've got that flag, remember, with the record flag, so that might think it's recording, but actually the process has stopped. So this is like a second check to see if it is actually recorded or not. Then I log an event, say that the infrared detections occurred, so I log the time and date. I log the IO pin on which the event occurred, and the result of whether or not we're currently actually, the command for recording is still running, so that gets logged to a file. And then I check those results, so whether or not, so this is whether the Python script thinks it's recording or not. So if the Python script doesn't think it's recording, because this is an event which has occurred saying IR motion has been detected, if we want to start recording if that's currently false, or we want to start recording if the check to see if the recording is still occurring, because if this flag is true and it's not recording, and we do want to start recording. For whatever reason, it's stopped recording. So we check to see if it's currently recording, and if it's not, also we want to start recording. Then we set the record flag to true because we're about to start recording, and we run the command, the shell script command, start recording. And then I do a log event to say that we've started recording in there. And I use my project, which is my beep project for the Raspberry Pi, to play an alert sound to say that it's started recording. Now you can, if you don't want the alert sound, either don't put the beep project on your CCTV camera, or you can comment this file out, this line out if you don't want it to play a sound. But that's just like an optional extra. And then the second function we've got in this program is to actually configure the GPIO. So we set GPIO warnings off. We set the mode to GPIO pin names, and it goes through all the pulse pins which we've got infrared detectors on, and it sets them all. If they're not, if the value isn't 0 of that pulse pin, then it sets it to an input pin and a pull up resistor on that input pin. So this is a note which I've got about Raspberry Vid. So this line is commented out. It would be an event detection thing, which is automatically call that function when it gets a detection on the I/O thing. But because there's seems to be an issue with using Raspberry Vid in the event detection, that it doesn't work. So we're actually going to be doing polling. Then we come to the actual program itself. So I'm going to so the check count is later on down in the main loop, which I'll come to in a minute. I want to do something every 60 seconds, but there's this period here which is every quarter of a second, which it was defined up the top. So as I'm going around the loop occurs 4 times every second. So I want to divide 60 by a quarter so that I make sure that when I do my check, it's every 60 seconds on the loop. Initially the record flag is set to off. This is just like initializing parameters that I have, and the trigger timer is set to the current time and date. It's kind of irrelevant, but it's always nice to set your variables before you actually come to use them at all. And then it calls a function to initialize the GPIO on the Raspberry Pi. So this is the main loop for the application, and it goes around infinitely. So I wait for the period of a second, so it's a quarter of a second then is the period. So this loop goes around 4 times every second, and this is where I do manual detection for GPIO pin getting triggered. Actually I've only done this for GPIO pin 0, so you'd need to put, if you want to do it on more than one IR detector, you need to put a while loop or for loop around this to do it for each of the items. It's something which I hadn't completed by the looks of things. But if the IR detector is triggered, then it calls the callback function to say trigger the recording. And then so if recording flag is true, so if it's currently recording, and what we've gone, so the current time is the last infrared trigger time plus minus the last infrared trigger time is greater than the record period, which is 60 seconds, the most that we want to record, or the minimum we want to record for a trigger. This says that if it's expired the time for between infrared detections, then what we want to do is actually stop recording. So we log an entry saying we're going to stop recording, and then I actually kill the process for Raspberry Vid. So in the shell function which actually starts the recording, I think it only starts the recording for a maximum of 1 hour, so I do maximum recordings of 1 hour at a time. So one way it would stop is if it gets to the end of the hour and it just stops recording, and then the only other way to do it, to stop it, is to use a system kill command, which is what this does, and then it says flags to say that we're not recording anymore. Okay, then periodically all this is doing is creating a log. So every 60 seconds it's just going to do write a log entry which writes the current date and time, what the current status of the infrared detection pin is, whether or not it thinks we're currently recording, and how long it thinks that we has been since it started recording. It logs that line. That's really just for debug purposes. So if the camera wasn't recording as I was expecting, then we can look at these log lines and see if it's not triggering properly, or if it's going over a period for some reason. Just as a sort of a safe check sort of thing. And then at the end of the program, although it never gets to here because it's in an infinite loop, it does the Raspberry Pi cleanup, GPIO cleanup, but might as well put that in there because at some point I might change the program so it does have a way of exiting, and it's just nice for completeness. So the next file is the index page for the web server. So there's one page on the web server, and that's this page. And then there's only like a couple of other files. One's the log file, which we saw earlier, gets copied across the last part of the log file. Then there's the JPEG frame, which is the current frame for the CCTV camera. And I think there might be another image as well, but I can't remember at this stage. So I've only so normally this would just be a web page, and I wouldn't sort of go into any depth of actually explaining it, but because I use a couple of features in here which are quite useful to use. So this first one is a JavaScript routine which I've created. It's called Ajax include, and all this does is, so I've got a page here, and if I want to include another page or piece of information from the web server, then I can use this to add that information to this page. So for example, where it's used here is to include the log entries onto this page. So I've got two files. Normally you wouldn't just be able to like show them both together unless you do like frames or something, but this doesn't go into the need to do frames. It actually pulls that information in it and displays it, and I'll show you how that happens. So here what you do is create a div element, and you give it a name, and then that div element you can style it however you want, but between the end and start and end tags for that div element, it's where it's going to pull that information for the log file. So we need then, after you've defined that div element, is to have a little bit of JavaScript where you call the function, which is the Ajax included defined at the top, the tag name, and then the name of the file which you want to pull off the web server and place into that tag, and then the result of, so what it does is it gets the tag name also. So this will actually display the text on the page, but then after that, because it's a scrolling element and I want to scroll to the bottom of it every time so that you see the last entries, well, I just get a reference to the log file div element, and then I tell it to scroll to the bottom of it. And that was the only real reason I wanted to include this file in the description on this video, is because that is an interesting bit of coding which might come in useful if you need it. Now I'm just going to describe, so when it's in photo image capturing mode, the CCTV camera, it uses a Raspberry Still utility which comes with the Raspberry Pi operating systems, and this just sets up the parameters you want to do, and I'm including it here because you might want to change some of the parameters. So the default resolution when you download the code is 1924 by 768. You might want to make that higher resolution or lower resolution, and also I set exposure to night because I use it at day and night, so it's always in night exposure. It doesn't seem to have made much difference during the day. It's a perfectly good image during the day as well as during night, so it's worth knowing that. You want to probably keep these bits of these arguments the same as what they are currently, because other bits of the system use these file names specifically for copying the files to the web server and things like that, so try and keep those the same, but you might want to change these variables at the front, so quality of 10, and yeah, and then in the same way there's a file for recording video. So I've got two lines in here because there's two standard ones that I use for recording. So one's like a medium resolution, one's a high resolution. So this is the medium resolution where I've recorded 1024 by 768 for a period of 1 hour. And this is the bit rate of the recorded image, so the quality of the image that it's recording. So I've tried to select a quality which seems to be really good quality, but without overloading the SD card by writing too much information to the SD cards. And again, exposure at night. And what you might want to is, so this is a rotation of 0 degrees. You might want to change the rotation of the, so you might need to put your camera at a different angle to like the angle I've got it. So you might want to rotate it 90, 180 or 270 degrees. So you can change that there if you need to. And then the high resolution one is just so I remember what the parameters are for recording high resolution. So 1920 by 1080, still recording an hour, and the bit rate is much higher because it's high resolution, but everything else is, all the other arguments are the same. But you might want to change those depending on your requirements. So next thing I've got is prune data. So this is just to point out that there's a script which makes sure you don't run out of disk space. So currently it's set to be in video recording, so you're looking at file extensions of H.264, and it gets the current use of the SD card, so how full it is, and it gets it as a percentage, and it does a comparison here, and it says if the usage of the SD card is greater than 90%, then it's going to go around this loop until it gets less than 90% usage. So it'll delete, and it'll delete the oldest files. So that's what this tail -1 does. So it does an ls, a list of these directory, the data directory, and it gets it orders it by date, and it gets the oldest ones, and it will delete the oldest ones. Oh, export data. Oh, sorry, that is the actual command, delete data. And then this, I'll guess so because this is before the while loop, so it needs to do exactly the same command in the while loop. So when it goes around the while loop again, it can check to see if it's 90%. And then at the end, I just output a summary of things. So this shell script, you can see what the oldest files are, the newest and oldest files on the data directory, and how much data use there is on data directory. And CCTV period. This is, I'm going to skip most of this because I'm just going to show you how good this is for hacking the H.264 video format. And it's really just this line here, and what it's saying is you can concatenate as many of these video files together as you want and just put them into a single video file. So you can take 3 video files. You can use the standard Linux cat command to add them all together and produce one single file which has been sewn together, and it seems to play okay in VLC. And finally, this is a web page. Well, it's not really a web page. What you do is run this locally on your local laptop, and it just brings in from, if you've got more than one CCTV camera, you can display them all on a single display. So you would change these IP addresses to whatever your CCTV camera IP addresses are, and I've got this one commented out, so if you had a 4th camera you could add that there, and then you can add extra, you just copy this block and keep pasting it, and then you can just keep adding as many as you want. Or if you want to make 3 per row, then you could copy that and paste it and make three items per row. But I'll show you the output of that. So this is how it looks when you output it. So then you could click refresh, and it pulls back the latest image from each of the cameras and puts them there, and that's all.